In the previous video, we talked about what the net change theorem said, kind of abstractly. And so in this video, I want to do a couple of examples, and they're going to be related examples, but they're going to be slightly different. So let's read through the problem. A particle moves along a straight line so that its velocity is v of t equals t squared minus t minus 6, measured in meters per second. Find its displacement between t equals 1 and t equals 4. Then find its total distance traveled during the time period between 1 and 4. So let me explain what the difference is between the two things that we are being asked here. Now, I know we're talking about a particle moving, but let's pretend that it's a person just for a moment. And let's say that a person was walking along a 10-meter pathway. And let's say that in whatever time period we're looking at, that person walked all the way forward and all the way back 10 times. So 6, 7, 8, 9, 10. Perfect. Okay. And then they stopped at the starting point. Let's say a person did that. If we want to know their displacement, that means how far they are at the end point from where they started. And in that case, that distance would be 0. If the person walked back and forth 10 times, their displacement over that time period would be 0 if they started and ended at the same side, because there's no difference between where they started and where they ended. That's displacement. That's the first part. The second part asks us to find the total distance traveled. Well, in that case, they went 10 meters forward and 10 meters back. That's 20 meters, but they did it 10 times. That's 200 meters. That is very different from the displacement. And I want you to understand the difference between those two things. The displacement, or the net change in position, and the total distance traveled. We're going to do both of these for this problem, and you're going to find that the first part is much, much, much simpler. So let's ignore the person and these 10 meters, and let's go back to this particle and this velocity function. So if we want to know the displacement from 1 to 4, that's the net change in position, all we need to do is we need to integrate that velocity function on the interval that we're given, so from 1 to 4. This is not that difficult. It's just a polynomial function. We've got t squared minus t minus 6 dt. And this is a continuous function, so the fundamental theorem of calculus applies, and we can use the second part to integrate here. If we do it term by term, that's going to give us t cubed over 3 minus t squared over 2 minus 6t. We've got to evaluate this at 1 and 4. When we plug in 4, that's going to give us 4 cubed, which is 64 over 3, minus 4 squared is 16, and 16 halves is 8, and then minus 6 times 4 is 24. And then we have to evaluate this at 1. That's going to be 1/3 minus 1/2 minus 6. And so let's see. Really quick on the inside, -8 minus 24 is -32. So this is going to give us 64/3 minus 32. And then when we distribute the subtraction on the other side, that's going to be minus 1/3 plus 1/2 and plus 6. Now 64/3 minus 1/3 gives us 63/3. And 63 divided by 3 is 21. So this is going to give us 21 minus 32 plus 1/2 plus 6. 21 minus 32 is -11, and -11 plus 6 is -5. And -5 plus 1/2 is -4.5, or -9/2. And so the displacement here is -9/2, and that means that the particle at its ending position is 9/2 or 4.5 units in the negative direction from where it started. It has moved 4.5 meters in the negative direction. That's what we get. That is the first part, which is the displacement. I'm going to label that part A. And then down here, we're going to do part B. Now, the second part is a little bit more complicated. To find the total distance traveled, what we need to do is we need to integrate the speed instead of the velocity, and speed is the absolute value of velocity, at least when we're dealing with something moving in one dimension. Things are moving in multiple dimensions, it gets trickier, but that's not something that we're worrying about here. So what we're going to need to do is we're going to need to integrate from 1 to 4 the absolute value of t squared minus t minus 6 dt. And we do not have a nice antiderivative of an absolute value of a polynomial. There's not a nice rule for that. So we have to put a little bit of thought in. And what we need to do is we need to figure out on our interval when this function is going to be positive and when this is going to be negative, the inside of the absolute value. Because when t squared minus t minus 6 is positive, then effectively we could remove the absolute values because it's already a positive function, and the absolute value of a positive function is itself. But if this is negative on any part of the interval from 1 to 4, then the absolute value making it positive effectively would take the opposite of it. So we need to figure out wherever this is negative, and for those intervals, we need to integrate the opposite of this. So let's look at this function, t squared minus t minus 6. What we can do is we can factor this. We need two numbers that multiply to -6 and add up to -1. That's going to be -3 and +2. And we want to know when this is greater than or equal to 0 versus when it's less than or equal to 0. And so basically, our interval is from 1 to 4. And we know that something interesting happens at 3. So that's going to be a critical number. So we can look from 1 to 4, but also looking at 3. And what we can do is we can look at each of the factors separately. So we've got t minus 3 and t plus 2. T minus 3 is going to be negative when we're looking at less than 3 and positive otherwise. And t plus 2 is positive on both of those intervals. We don't need to look at the outside intervals because we're only interested at what's happening from 1 to 4. And so our function here, we can see from our sign chart, is going to be negative from 1 to 3 and positive from 3 to 4. So what we need to do is, first of all, we need to split this up into those two intervals. So we need to look from 1 to 3 of this function in the absolute value. And then we need to add the integral from 3 to 4 of this function in the absolute value. And from 3 to 4, our function is positive, and so the absolute value symbols don't do anything. So we can simply get rid of them there. When our function is positive, we can replace them with parentheses. When our function is positive, taking an absolute value doesn't do anything, and so we can just integrate that function. But we know from 1 to 3, our function is negative, and when you take the absolute value of a negative number, the way that it turns it into a positive is by taking the opposite. So for this interval, we need to integrate the opposite of the function, which is going to be negative t squared plus t plus 6 dt. All right. So we're going to go through and do these calculations in just a moment, but very quickly first, just to review what we did, because we're looking at the total distance traveled, we need to integrate speed instead of velocity. And speed is the absolute value of velocity when we're looking just in one dimension, positive or negative. And so we have to integrate the absolute value of this function. And to do that, we need to look and see which parts of the interval of integration it's positive and which parts it's negative on. When it's positive, we can just integrate the function without absolute values. But when it's negative, we need to take the opposite of that function, because the opposite of a negative function is positive. And then we just need to do all of these calculations and we are good to go. So what we need to do here for this first one is take the antiderivative. And that's going to be negative t cubed over 3 plus t squared over 2 plus 6t, evaluated at 1 and 3. And then we need to add to that t cubed over 3 minus t squared over 2 minus 6t, evaluated at 3 and 4. And so you need to evaluate this first one at 3 and then subtract what you get when you plug in 1. So this is going to be negative 3 cubed over 3 plus 3 squared over 2 plus 6 times 3, minus the same thing with 1 inside, negative 1 cubed over 3 plus 1 squared over 2 plus 6 times 1. And then we need to add this second part. So we've got to plug in 4 and 3. So that's going to be 4 cubed over 3 minus 4 squared over 2 minus 6 times 4. And then we need to subtract what we get when there's a 3 there. So that's going to be 3 cubed over 3 minus 3 squared over 2 minus 6 times 3. And oh darn, I'm out of room. So I'm just going to tell you that all of this is equal to 61 over 6, which is approximately 10.17 meters. I am being lazy and not doing those calculations, but I trust that you are all calculus students. You are able to do some arithmetic with fractions. It will take a few steps. You're going to have to do a handful of calculations, but I trust that every single person watching this video at this point is capable of doing that, and you do not need to see me go through those steps. So the important part here is understanding the difference between finding the displacement and the total distance traveled, and understanding how we deal with an integral of an absolute value by breaking up the interval into the parts where it's negative and positive. And when we're integrating the portions where it's negative, oops, that's this side, taking the opposite of the integrand.